Hey math fans, it's test 5 lesson 2. Get your swords ready and let's go. Today we will be writing coordinates, expressing probability, and talking a little bit about ratio. And we will start by writing some coordinates. So just to review, we plot coordinates as x, y, and we put them in brackets like this just to make them stand out so that if I'm writing them, you can always find the coordinates really easily. If I was making a list of coordinates and I didn't put brackets in it, it would be really confusing because it would look something like this. And you can see how that would be annoying. So we stick them in brackets like that, or parentheses, just to make them stand apart a little bit. Remember, coordinates don't have to be numbers. They could be letters or anything, really. And we plot the coordinates along lines or inside boxes. So I can make a graph that looks like this. And remember, the y-axis is the one that I can make into a y. That's the y-axis. This is the x-axis on the bottom. So for example, if I was going to plot 1, 3, I would find 1 on the x-axis because x comes first. And 3 on the y-axis, I would find where they intersect, and that's where I would plot it. I can also do it, though, if I wanted to, for example, on a map or something, I can make a grid, and it would be the same. So 1, 3 on here, it would probably look like this. This would be grid 1, and then this would be grid 3, so I would go in there. Okay, so that's just a quick review of basic coordinates. And honestly, that's all I really wanted to say to you about coordinates. So I'm going to move on, and we are going to talk a little bit about probability. And to talk about probability, we're going to go back to math is fun. So, probability is how likely something is to happen. Remember that many events can't be predicted with total certainty. The best we can say is how likely they are to happen using probability. And so again, we have the idea of tossing a coin. There's two possible outcomes, heads or tails. So the probability of landing on heads is 1. There's only one way you could get heads out of 2. There's 2 possibilities. And same for tails. Dice is kind of the same. When a single die is thrown, there's 6 possible outcomes, 1, 2, 3, 4, 5, or 6. And the probability of any one of them is 1/6, because there's only one way you could get a 1. There's only one side of the die that has a 1 on it. And there's 6 choices, so you'd have 1 out of 6. So in general, the probability of an event happening is the number of ways it can happen over the total number of outcomes. So, for example, the chances of rolling a 4 with a die, the number of ways it can happen is 1. There's only one face with a 4 on it. The total number of outcomes is 6 because there are 6 faces altogether, so the probability is 1/6. Here is another example. There's 5 marbles in a bag, 4 are blue and 1 is red. So what's the probability that a blue marble will be picked? Well, how many ways can it happen? 4, because there's 4 blue marbles. And the total number of outcomes is 5, because there's 5 marbles in total. So the probability is 4 out of 5, and you can also write that as a decimal, 0.8. One other thing we can do is show probability on a probability line. And remember, we've discussed before that probability is always going to be between 0 and 1. So 0 means that an event is impossible. If the probability is 0, the event's impossible. There's a 0 probability that the sun will be purple when it comes up tomorrow. That is not possible. It's not how our universe works, so the probability is 0. If the probability is 1, then it is certain. It is the probability of 1 would be that winter will come after fall. That always happens. It's definite. It's going to happen, so the probability is 1. It's 100%. The rest of the probabilities come in the middle of the number line somewhere. So if there's an even chance, 50-50, for example, tossing a coin and getting heads or tails, that would come right in the middle of the number line. Lower on the number line, so in between 0 and halfway, would be an unlikely event. So for example, we talked about the die. Getting a 4 on the die is a 1 in 6 chance. It's unlikely because 1 out of 6 isn't very good. It's not a very good chance. Likely, on the other hand, would come closer to certain, and that would be like the marbles. You have, if you're getting to pick one of these guys and you want the blue one, you have a 4 in 5 chance. It's likely that you will get a blue marble. So these are just some words we use to describe probability. Impossible, unlikely, even, likely, and certain. Remember, though, that probability is just a guide. It does not tell us exactly what will happen. So, if you toss a coin 100 times, we've talked about this before, theoretical probability says that you have a half chance of getting heads, so you would expect 50 heads. But when you actually try it out, so the experimental probability might give you 48 heads or 55 heads or anything, but most of the time it's going to be near 50. And like I said before, the more times you do it, the closer you're going to get to the theoretical probability. So basically, anytime someone asks you to give them the probability, what you want to write down is the number of expected outcomes, or we sometimes say desirable outcomes, on the top, and the number of possible outcomes on the bottom. So what you're seeing here, this is a picture of an 8-sided die. So it has 4 sides at the top, there's one you can't see over there, and 4 on the bottom. So if I asked you for the probability of rolling an 8, you would figure out how many ways there are that you could get the desired outcome. And in this case, the desired outcome is getting 8. So how many ways are there you could get an 8? There's only 1. So that goes on top. And the reason there's only 1 is because there's only one face of the die that has an 8 on it. And on the bottom, you're going to put all the possible outcomes. So how many possible outcomes are there? There's 8 possible outcomes. So the probability of rolling an 8 is 1/8. The probability of rolling an even number would be different. But we're still going to figure it out the same way. So I'm going to figure out how many, sometimes it's better to start at the bottom. How many possible outcomes are there? There's still going to be 8, because there's 8 possible numbers I could roll. What is the probability of rolling an even number? Well, I could roll a 2, a 4, a 6, or an 8. All of those would be even. And there's 4 ways I could roll an even number. So the probability of rolling an even number is 4/8, and some of you may realize that that fraction is equivalent to 1/2. So it's a 50-50 chance of getting an even number. So here's your review. And sorry, it's a little bit squishy. All right. Sorry, just fixing something there. Number 1, in this picture, what is the ratio of hearts to stars? And I know we didn't talk about ratio yet, but you are smart kids, and we've done it before, so you can do it. Number 2, in the grid below, what are the coordinates of the x? And number 3, look back at that picture from question 1. And A says if you close your eyes and pick a shape, what is the probability that you would pick a heart? B says if you take one of those hearts away, you close your eyes and you pick a shape, what is the probability of getting a heart now? So do the review, pause here, do the review, and when you come back I'm going to send you away for a really quick STEM bite. So here's the link to the STEM bite. It's www.tinyurl.com/sbratio. As usual, if you can't find it, just go to YouTube and search STEM bite ratio and it'll turn up. Very short, kind of fun. Have a good time watching it, and I'll see you tomorrow.